Hello, going through the Advanced Math Topics 3.9 worksheet on real life application or real life problems with trigonometry. Number one here, it says a ship passing through the Strait of Gibraltar connecting the Atlantic Ocean and the Mediterranean Sea. The closest the ship gets to Gibraltar is 2,400 meters. That's right here. Later, the ship is 2,650 meters away, right here. So the ship is kind of moving in this direction. Okay. Find the angle of change from the position. So this is a right angle because the closest we get is a direct line along the perpendicular. Okay. So I have this angle of interest. I have this adjacent leg. And I have the hypotenuse because this is across from that. I'm going to thin my pen out here a little bit. Okay. So again, we're going to go back to our SOHCAHTOA for starters here. And if I'm using A and H, that's got to be cosine. So I'm going to say the cosine of theta, which is our variable that goes with trigonometry and angles. So it's going to be the adjacent over the hypotenuse. Now again, we're looking for the angle, so I got to get rid of cosine, so I'm going to do inverse cosine of this fraction. Okay, so now I'm going to find the angle. I'm going to go probably one decimal place here. So I'm going to fire up my calculator here. Okay, and I'm going to go inverse cosine of 2400 divided by 2650. Close it off and hit equals. And I get 25.1. So 25.1 degrees. Alrighty, so a little right triangle trig with SOHCAHTOA being used here. Number two, Tom, Rich, and Harry are camping in their tents. Okay, so it looks like we have T, Rich, and Harry. If the distance between Tom and Rich is 153 feet, the distance between Tom and Harry is 201 feet. And the distance between Rich and Harry is 175 feet. What is the angle between Rich, Harry, and Tom? So we're looking for this angle right here. If I go Rich to Harry to Tom, that's that angle. Now, they didn't say anything about right triangle. The diagram, we're not sure. So we are going to use the law of cosines because of the fact that we have this across from this with these sidewinders. So now we're going to say 153 squared equals 175 squared plus 201 squared minus 2 times 175 times 201 times cosine of x. So now that means we have some calculating to do here. Remember, we're going to subtract these guys over. Subtract them over to this side too. These cancel, leaving me a new expression. So 153 squared minus 175 squared minus 201 squared equals negative 47,617 equals negative 2 times 175 times 201 times cosine x. Now we're going to divide by negative 2, 175, and 201. Do that over here, negative 2 times 175 times 201. So if I divide by negative 2 times 175 times 201, close it off. Again, parentheses, very important. And I get 0.68 equals cosine x. And again, we know that to get rid of cosine, we do cosine inverse of 0.68. And if we round this to the nearest degree, that's fine. So now I'm going to go ahead and do inverse cosine. Oh, I got to clear. I'm going to do inverse cosine of 0.68 and hit equals. And I get x of 47 degrees for this x right there. Okay, so again, that was not a right triangle. We had to come up with either law of sines, law of cosines. Next one, a plane leaves JFK Airport, International Airport, travels due west for 570 miles an hour. Another plane leaves 20 minutes later and travels 22 degrees west of north at the rate of 585 miles per hour. To the nearest 10 miles, how far apart are they 40 minutes after the second plane leaves? Okay, so again, we got this. So we have JFK, the airport there. This plane leaves, and it's going to be at 570 times h for hours. Leaves 20 minutes later, travels west of north. So here's north. 22 degrees would be about this right here. And it's going at 585. So it's going a little faster per hour. And they want to know, so this is 20 minutes later, 40 minutes, so this is 60 minutes. So this is 1 hour here, so this is going to be 570 times 1 for this distance. Over here, this is going to be 40 of 60 minutes, so that's going to be 585 times 40 divided by 6 miles. So I'm going to go ahead and calculate that. I'll fire up my calculator again here. So I'm going to take 585 times 40 divided by 60. That gives me 390 miles here. Okay. So I want to find this distance here. I'm going to call it x. Now, one other thing here, we need a little more info. If this is 22 degrees and this is 90 degrees, 90 minus 22 equals 68 degrees. So this angle inside this triangle is 68 degrees. So now we have this across from this, and we have these two sidewinders here. So this will be law of cosines again, but this will be the easier version because it's going to be x squared equals 390 squared plus 570 squared minus 2 times 390 times 570 times the cosine of 68 degrees. So this one's not going to be quite the amount of work as a previous problem. So if I take 390 squared plus 570 squared minus parenthesis 2 negative 2 times 390 times 570, close it off, and then times, let me go back, and then minus cosine of 68 degrees. Okay, so I get a big number, 921,600. I'm just going to leave it at that. But now I got to square root both sides. So now I'm going to square root. So I'm going to do a square root. And I get x equals 960 miles. So the two planes will be that far apart 40 minutes after the second plane leaves. Okay, continuing on here. A couple more left, it looks like. Matt measures an angle of elevation of a peak of a mountain is at 35 degrees. So what we have here, we got 35 degrees, and here's the mountaintop right here. Susie, who is 1,200 feet closer, on a straight level path, measures the angle at 42. Oops. So 42 degrees. Okay. How high is the mountain? Okay. So we have, let's do here. We have a right angle here. We're looking for this. Let's call this x. And we have to go ahead here and we got to put another variable here, and we're going to call this y. Okay. So the first thing we have to do here is I can go ahead. This is a linear pair, so that's going to be 180 minus 42 equals 138. So this is 138 degrees. Alrighty. And, well, that's this part here. Right from here to here is 138. I can figure this out because of 180 minus the 35 minus the 138. And that's going to be what? 173. This is going to be 7 degrees up here. Okay. So, with that, we can go ahead and find this length here. We're going to call this M. So 35 is across from M, as 7 degrees is across from 1200. Okay. So first of all, I'm going to say the sine of 7 degrees over 1200 equals the sine of 35 over M. Because once I find M, then I can use some right triangle trig right here. I can use M42 and x here. So it's important to find M first here. So this is a pretty complicated problem here. So again, but now once I have this, I know I can take these two guys and divide by that to get M. So that, using the law of sines, a little bit easier than some other things here. So I'm going to take 120 times the sine of 35, close it off, and divide by the sine of 7. So M is 565 feet, we'll say. So I'm going to redraw that pink triangle. So now mountain's height is based on a perpendicular. I'm looking at x. This is 42 degrees. And this is 565 feet. So now what trig function in SOHCAHTOA deals with the opposite and the hypotenuse in our SOHCAHTOA? And it's going to be this one here. So I'm going to say the sine of 42 degrees over 1 equals the x over 565. So now this one I'm just going to multiply this and divide by 1. And we'll round this to the nearest foot. And so now I'm going to clear. I'm going to get 565 times the sine of 42. And that gives me 378 feet tall for the mountain, or the peak. That's not really that tall for a mountain, actually. Granddad's Bluff is, 100 plus feet higher than that. Okay, just about done now. Last problem. A triangular playground has side lengths of blah, blah, blah. What are the measures of the angle between the sides to the nearest tenth of a degree? So again, we have 475, we have 595, we have 401. Let's start with the largest angle. I'm going to call it x. I'm just picking that, and I have this across from this, sidewinders. So first step is to say that 595 squared equals 401 squared plus 475 squared minus 2 times 401 times 475 times the cosine of x. So this is a long version of the law of sine, or law of cosines here. So I'm going to take 595 squared and subtract off 401 squared and subtract off 475 squared. Okay, so that gives me 332, 401 negative. And now I'm going to divide that by negative 2, 401, 475. I'm kind of coming up with some shortcuts here. Okay, so I'm going to divide by negative 2, divide by 401, and divide by 475, and I get 0.085 for cosine x, and so that means x will be inverse cosine 0.085. So now I'm going to go ahead, inverse, I'm using my phone today, so it's a little different than my usual handheld calculator. So I get x equals 85 degrees. So this one's 85 degrees. I'm going to switch colors now. Now I have this across from this, and let's call this one, we'll call that y, across from 401. So I'm going to say the sine of y over 401 equals the sine of 85 over tenth of a degree, so this should have been 0.1 degrees, sorry, 595. So now I'm going to multiply these guys, divide by that to get sine of y. So I'm going to go 401 times the sine of 85.1, close it up, oops, and then divide by 595. I get 0.67. So now I'm going to do my inverse sine on 0.67. 0.67. And I get y of 42.1 degrees. And then finally, since I know the two angles of a triangle, to find a third, I'm going to call it z. So z is going to equal 180 minus 85.1 minus 42.1. So clear out. 180 minus 85.1 minus 42.1 equals 22.8. So z is 22.8 degrees. So we have my three answers here. Here's 1, here's 2, and here's 3. Well, hopefully this helped you get through your assignment. Again, you're not going to see anything this difficult, probably an average day in your life, but it's something that these are all doable type problems.